Okay, so our objective is to use information from our field trip to Jim Norton Toyota to derive or come up with a general formula for calculating car payments. So let's look at some things that we learned at Jim Norton. First of all, we were looking at buying a car for $15,000. But if you noticed in his tool that he used, there was a $259 fee that he didn't really talk about. And so the total price was actually $15,259. That's what he got his numbers with. Now, without any interest whatsoever, that the payments were going to be $254 according to his program, and that was simply $15,259 divided by 60. That would equal 254. That was one of the things that was given to us, and this was at 0% interest. Now at 3.5% interest, we were told that same $15,259 finance price would result in a $277 monthly payment as opposed to the $254. The difference is going to be the interest charges. They also told us that a 4% on that same $15,259 would result in a $281 car payment per month. So how do they get these from these percentages? This is where you can use your understanding of math and algebra to create yourself a formula that you can apply more generally when looking and thinking about your car purchases. Let's talk about how we would get to that. Well, first of all, we need to figure out what this difference is here, and it's the amount of interest. Well, we know that the amount of interest, the annual interest rate, is 3.5%, and if we were to multiply that, we would use the decimal equivalent of that, and we would multiply that times the amount that we're financing, okay, and then we'd multiply that by the number of months that we're financing. But this is an annual rate, and we need to be multiplying the monthly rate times these two factors in order to get what would be the total amount of interest per month here, and then times 60 for the total amount of interest. Well, it's not 3.5% because that's an annual rate. This is divided by some factor here, and that's going to be what we have to figure out, is what is x. So that's the mystery variable. So this right here, this equation right here, expression right here, represents the amount of interest that we're paying. The difference between $254 a month and $277 a month is represented here. So we have to add this back to our original finance price, divide the entire thing, because this will give us our total interest plus our principal, divide that entire thing by 60, and that will equal our $277. The trick now is to solve for x. So let's solve for x here. First of all, I have this large fractional component down here. One of the math rules is you can take something from the denominator, move it across to the other side of the equal sign, and put it in the numerator. So instead of dividing this whole thing by 60, I can multiply this by 60 and just move this to this other side. So that would change my formula to look like this. 0.035 divided by x times 15,259 times 60, all in brackets. Didn't change anything there. plus 15,259 is equal to 277 times 60. So that's one of our algebra rules. I can move that over there, rewrite this expression as such. Then I can literally do that math right there, and I would come up, if I did, with this side equaling 16,620 over here. This side is still equal, right? This expression to this expression. And if I'm also trying to get rid of this, trying to move that to the other side of the equal sign, I just subtract it from both sides. It's a positive value here, so I can make it a negative value on this side, which will cancel that out, and I'll make it a negative value over here. So I can simply do this and say minus 15,259. Right? And if I was to go ahead and just calculate what that is 1,361. So this represents the amount of interest that we're being charged, because this term dropped out. It was the principal, and I told you that everything inside the bracket was the interest. So I'm going to rewrite that here now. 0.035 divided by x times 15,259 times 60, right? All of that is equal to 1361. So as we continue here, now I've got this x is in the denominator of this fraction, and when you're multiplying like this is over 1, this is over 1. So all of these three terms, this term, or this value, and this value, they are all in the numerator. This is the only one in the denominator. One of the math rules is we can move something from the denominator to the other side of the equal sign as long as we move it to the numerator. We can also move something from the numerator over to the denominator. So in this case, I can exchange places with x and 1361. And it would look like this. 0.035 divided by 1361 times 15,259 times 60 is equal to x. So I now have my x. Now all I have to do is calculate this out to know what it's going to equal. Let's just do that real quick. Okay. 0.035 divided by 1361 times 15,259 times 60 is equal to 23.54. So 23.54 is equal to x. Now that is actually a constant, and we can apply that constant in this way. Here's if I instead of writing our initial expression with numbers, this is our initial expression, right? I'm going to replace this initial expression with, instead of numbers, with what we would call those variables. We'll do that right down here. I'll leave that up there so you can reference it. I'll write it down here. We would start off with our interest rate divided by 23.54, which is our constant we just calculated based on the information we got from Jim Norton Toyota. This times our price, which includes our fees, times our months, number of months, plus our price, all of that divided by the number of months, and that's going to equal our monthly payment. So this is our generalized formula that we can use to calculate our payments on any car. So I told you that, remember, our one of the things that we also learned was that at 4% it was going to be $281. So what we need to do is, what we can do is we can go back and plug in this 4% to this equation we just came up with to see if it works. So let's just try that. 0.04 divided by 23.54 times 15,259 times 60 plus 15,259 all divided by 60. Let's see what that equals. It's supposed to equal about 281 according to their system. So let's see if we can get to that. 0.04 divided by 23.54 times 15,259 times 60 is equal to that. So our interest that we're going to be paying is $1,555 plus 15,259 in principal. So the total that we're going to end up paying is $16,814. Divide that by 60, gets us $280.24. $280.24. It's very, very, very close. It's just some rounding error, and we have proven, at least with 2 examples, that this is a formula that we can use to calculate monthly payments on automobiles, as long as we know the annual interest rate and we remember this constant. If you remember, Justin said that they actually used 24, they round this to 24 to do rough estimates to make the math easier. But if you use 23.54, you might be just a little bit more accurate. Now, what your goal is to take this formula that you just watched me derive and apply it to one of the cars that you researched online and figure out what your monthly payments would be as if you changed the interest rate. Maybe you show me 2 or 3 different interest rates versus 2 or 3 different lengths of your loan to calculate a couple of different monthly payments over here. That's a great exercise for you, and you should see this shown in your PowerPoint with this equation and how you've applied it.